Hi again everyone. This time we're looking at an introduction to the electronics breadboard, and I have one right here. With so many of my projects, the first starting point is going to be this electronics breadboard. So the resistors that we've been haven't spoken to any resistors, we've been talking about resistors. These easily, or the ones with the legs, easily plug into an electronics breadboard. So if we were to get multiple resistors, we could connect up different series circuits, or later on we'll talk about parallel. We can put in capacitors and transistors and inductors and integrated circuits. All sorts of things can plug right into this breadboard to make complete circuits. So let me show you what I mean. Here is an example of one of my projects. So you can see this video just up here, should be playing. So basically this is the finished product down here. I called it the DigiPixel. It has 64 RGB LEDs in it, which we'll learn about later, a whole heap of buttons and some chips and resistors and transistors and all sorts of things on it. This would then plug into a programmable board known as an Arduino. You'd then program it to make little games and cool little things, as you can see up here. I feel like the Brady Bunch, pointing to different things in this same video. The breadboard version, if you have a look over here, this is my original prototype. So before I even designed the circuit board here for it, I wanted to make sure the circuit worked, and as you can see I've got two of these breadboards. The LED screen would fit between the two. My Arduino would then plug in over here. So these breadboards, even though I've only got one component in here not doing much at all, you can see that we can really make complex circuits with these breadboards. So if we check out a few different breadboards, I've got different sizes here. I've got, well, let's start at the really small one. I've got this one here, then we're getting a bit larger here, here, and here. And they've all got their own tiny little differences. In fact, this one and this one are basically the same as each other. This one's just pretty much half the size of that one. First of all, let's just have a look at this one, because I've actually taken the back of it off, just so we can see how these, internally, how the connections actually work. So first of all, you notice that there's heaps of holes all over the place. But there's different patterns of holes. If you have a look down the bottom, we've got a group of 5, then a space, then a group of 5, and then it just keeps going across like that. This is repeated all the way up the top here. If we flip it over and have a look at the back, see what's going on there, that group all the way at the top and down the bottom, they're all connected together with a piece of wire. If we have a look at the stuff in the middle, you notice that this has got a group of 5 high, and then it goes all the way along, keeping a group of 5 high. In fact, let's look at this one just a little bit more closely. Got a little blade here. Just going to try and pry this open a little bit, just so you can get an idea of what's going on. Try not to cut myself. There we go. Okay, so I've taken that one out. So if we just have a bit of a look, when you actually plug your component in, for example, if I was to grab a resistor, let's pick it back up again. If I was to grab a resistor like this, when you put it through the hole, it actually comes through like that. And when it's actually in the hole, this makes a pretty good grip and it grabs onto it. So this is just one solid piece of metal. So anything that I put in any one of these holes, or if I put a resistor, say, in that hole there like that, any of those other 4 holes are going to be connected to that leg of that resistor. And so they're connected in groups of 5 vertically, and then they're all separated from each other as you go across horizontally. However, these ones, that's all connected horizontally. That top one, all connected horizontally like that. So with this grouping of horizontal and vertical patterns, we can make some pretty complex circuits. If we have a look at this one essentially only has that stuff in the middle. It doesn't have any horizontal connections whatsoever. So these ones are good for prototyping just really small circuits. If you want something just a bit bigger, we can go to this one. Now, the benefit with this particular one is that not only do we have one horizontal row down the bottom here, but we've got a second one, but they're separated from each other. So that one, all of those holes down the bottom there, just one solid piece of wire connecting them, and then separate to that is another identical solid piece of metal going across, and then that's repeated up here as well. Now you may notice there's a negative and a positive sign on these ones, really good for when you want to connect a power supply up. And then we've got that same pattern as before, so we've got groups of 5 vertically in here. Now you may also notice we've got this gap in the middle. So every single one of these has a gap with nothing in the middle there. The reason for the gap is if you were to get something like, let me just grab a chip, So here's a bunch of chips that I've got here. Take one out. So there we go. There's a microchip. So these have legs down the bottom and legs up the top, depending on which way you're looking at it. Now, if we were to get one of those and plug it straight in, let's just grab this board for example. If I was to plug it straight in there, remember these holes are connected vertically. So I've just shorted out, as in I've just connected with a straight piece of metal, the top leg to the bottom leg. And that chip's just not going to work. So what we need to do is connect that across like that. So now when I want to start connecting wires and components, I've got 4 holes below each one of these connections, and then 4 holes above each one of these connections with which to connect to it. So that's why we've got those gaps. Alright, so now let's have a little a look at an actual circuit, so the one that you can see on your screen right now. And let's build that circuit on, okay, let's go with this board. So this one is probably the most functional board. Now the first thing I'm going to do is connect up a power supply. So these 2 wires here, so one is, well, black and red, but I'm just going to call it the black wire, and one is a solid red wire. This is my negative, and this one over here, this is my positive, and that's coming from my power supply. So the first thing I'm going to do is connect my power supply up. So I might put my negative down to there where it's called negative, and I'll put the positive up to here to the positive connection. So now if we follow this through, my negative from my power supply is connected to every single one of those holes that's in the same row as where I've just connected it. So any one of those holes, I've got a connection to my negative of the power supply. If we look up the top here, the positive goes to this hole here, so any other hole in that same horizontal line is going to be connected to the positive. So now if we continue this along, I've got a resistor right here, which is one of my 1K resistors, and you'll notice that it connects from ground, or it connects from the negative connection, and it goes up. So I'll do that. So remember, it doesn't matter which one of these holes I put it in, as long as it's in the same horizontal connection to there, I'll get a connection to the negative. So there's the first connection. I'll do it right over here. Oh boy, there we go. And then I'll put that, it doesn't really matter where I put it, but let's just say that I put it there. So if we follow this along, we go from negative all the way through this piece of metal to the bottom of this 1K resistor. We're now going through that 1K resistor to here. So we're in this hole there. So we've got 1, 2, 3, 4 holes above that hole. And remember, the way these are connected in there is they're connected with these pieces of metal in 5 vertical holes. So let's get the second resistor. So here's another 1K ohm resistor, and if you follow the circuit diagram on the screen, I need to connect one of these legs to the top of this one that I just put in, so any one of these holes above it would be fine. And then I need to complete the circuit. The last piece of the puzzle is this one goes to the positive of my power supply, which is right there. And there's my complete circuit. From the negative of the power supply, all the way along here, because that's just a piece of metal, to the bottom of this 1K resistor. It goes through the 1K resistor to this hole. It then, remember, these ones are connected vertically, so the very hole above that is connected to the bottom of this resistor, so it goes through that resistor to this hole here, and if we follow that all the way along horizontally, we get to the positive of the power supply. So there's our complete circuit. And we can manufacture some pretty complex circuits with this, just as I showed you before with one of my projects. And we're going to do lots with these later on as well. We're going to include multimeters and pretty cool things like that. But draw your attention back to, well, you're already looking at the screen, aren't you? But I'm going to draw my attention to the screen. So if you have a look at this, we've got what's called Fritzing. So if we have a look at the internet, go to fritzing.org, and then you can go to the download section. There's a really cool open source piece of software. And when you download it for Windows, Mac, or PC, Windows, Mac, or Linux, and you can feel free to give them a donation. It's a really cool piece of software. But you'll notice that there's the same sort of breadboard as this one that I built the circuit on. So you can start to come along over here to their parts, and I can grab myself a resistor over here, and I can drag that over. I can extend the, if I grab it properly, I can extend the leads of those resistors if I want to, or I can make them shorter. I can, forgot how to rotate. Let's rotate it 90 degrees. There we go. So I can put one of those in. Now notice this is pretty cool. Put that in there. Notice how these holes up the top here, they're all green now. It's showing me that that resistor there is connected to that hole. Now every other one of these green holes is connected to that top of that resistor there. And then if we follow this one down, we've got all these green holes. So that means that that one, that one, that one, and that one are all connected to the bottom of that resistor. So if I wanted to finish off my circuit, I might get another one of these resistors, and I'll rotate that, and then I'll plug that in between there and there. So there's my complete circuit. So this would be the negative of my power supply, and in fact I could get something like a wire, like one of these ones. Oops. So I might connect that, there we go, that would go to my negative, and that would then go off to my power supply. And then I'd get another one of those, and then that would go to my positive, and that would go to the positive of my power supply. So we can actually draw circuits without actually having a breadboard like this. So that's a really cool program. Okay, so that's it for breadboards. Hopefully you found that pretty informative. Really, really good to use these breadboards to manufacture your circuits, and then perhaps you may want to go on to making a circuit board later on, which I'll certainly give a lecture about. Thank you guys for watching.